Hello friends, and my dear students, I welcome you all to my channel. This video is part of the playlist NCERT FingerTips Mathematics Class 12, where I will try to solve problems on the chapters of Mathematics Class 12 from the textbook Objective NCERT at your fingertips. This is part 3 of the problem solving series on integrals from the textbook. If you have not watched the previous two parts, I will highly suggest you please watch them. Uh, in the previous video, that is part 2, I failed to solve a problem. So in this video, I will start by solving that problem first and then the remaining another 5 set of problems. So let's get started. Okay, so as usual, I have kept as a reference all the standard integral formulas on the left hand side and some trigonometric functions that I might need in solving the problems, and on the right hand side I will solve the problems. Let's first solve the problems which I failed to solve in the previous video. I tried a lot to solve it offline, but I couldn't, and then I was referring the textbook NCERT fingertips, and over there is a tip. There is a tip how to solve this kind of problem. So the problem was integral of sec x to the power 4 by 3 multiplied by cosec x to the power 8 by 3 dx. Okay, so the tip was that if you have this kind of the concept of the formula is that if you have integral of the form sine x to the power m and cos x to the power n dx, where m plus m is negative even integer if m plus n is negative even integer, then the substitution should be, you should substitute tan x equals to t. So let's see over here, you can see 4 by 3 plus 8 by 3. So basically this is, if we translate this to into sin x and cos x, this becomes cos x to the power minus 4 by 3 and sin x to the power minus 8 by 3. And if we add over here n is minus 4 by 3 and m is minus 8 by 3. If we add minus 4 by 3 and minus 8 by 3, we get minus 4, which is an even negative integer. So we substitute tan x equals to t. This implies sec square dx equals to dt, and then the integral becomes okay, so this implies okay, so therefore the integral becomes this implies cos minus 2 x dx equals to dt. From the integral, I would like to take out this cos x to the power minus 2. So if I take out this factor from the cos x to the power minus 4 by 3, I am left with plus 2 6. So 2 by 3 cos x and sin x 8 by 3. Sin x 8 by 6 square x we have sin x minus 8 by 3 this. Now this becomes this for x. So now if I substitute cos x to the power minus 2 dx by dt, I get this multiplied by uh, cos 2 by 3 tan x. Okay, so fine, and we have cos x to the power 2 by 3, and if I take sin x to the power 2 by 3, and over here I will be left with sine 2 by 3 so I have to multiply it by 2 by 3 x, and over here I have minus 8 by 3. This becomes sin x 2 by 3 minus 6 by 3. This becomes dt by tan x to the power 2 by 3. Tan x to the power 2 by 3. Over here what we get? Sin x minus 6. We get sin square x. What next? I forgot the solution. Let me please check the solution. I solved it. Where did I solve it? Over here. Yeah. So tan x equals to t. Okay. Sin x by cos x equals to t. Sin x by sin square x equals to t square by tan. Okay. Sin square x. Okay, I was doing it right, but I got stuck. So now I have this thing. Okay. Now I have to get sin square x in terms of t, and I know that tan x equals to t. So I substituted tan x equals to t. This implies sin x by cos x equals to t. This implies sin square x plus cos square x divided by cos square x equals to 1 plus t square. This implies cos square x equals to 1 by 1 plus t square. This implies sine square x equals to 1 minus 1 by t square. This is 1 plus t square by 1 plus t square. So this integral becomes dt by tan x was t, so t to the power 2 by 3, and sine square x we got t square by 1 plus t square. This is 1 plus t square by t to the power 8 by 3 dt. Now this is easy. We have t to the power minus 8 by 3 dt plus t to the power minus 2 by 3 dt. This becomes plus 1 t to the power minus 5 by 3 divided by minus 5 by 3 plus 1 by 3 1 by 3 and the constant of integration. So this becomes minus 3 by 5 tan x minus 5 by 3 plus 3 into tan x to the power 1 by 3 and plus constant of integration. I might do some mistake or wrong in the powers or in the factors, some silly mistakes. If you find them, please do let me know in the comment section. I will appreciate that. Okay, this was the problem that I failed to solve in the previous video. So this was the concept that if you have an integral of sin x, cos x and some powers of them, and if the powers add up to be a negative even integer, then the substitution you should make is tan x equals to t. Okay, now let's solve the new 5 set of problems. The one. Okay, so the first one is cos square x into e to the power log sin x dx. Now over here, if you substitute very first approach might be method might be to substitute sin x equals to t. Will that help? Cos x. Or we should, what is log of sin x, derivative of log of sin x is cot x. We have cos x square x, means 1 by sec square x, cos x square x. No, I think the easy approach will be to substitute, let sin x equals to t. This implies cos x dx equals to t. Therefore, from here we can, okay, so the integral becomes cos x dx, sec square x, cos x square is 6 square x. Okay. What if we substitute 10x equals to t? Then we will have 6 square dx. No. Okay, let's see what happens. Cos square x. Sin x. E to the power log. 1 second. E to the power log sin x is basically sin x. Sorry. So we have to first use the logarithmic properties and simplify it, reduce it to a more simplified form. So this basically becomes cos square x into sin x dx, as we know the logarithmic properties a to the power log base a b equals to b. So over here log, nothing is, base is not given, meaning the base is e and it is e to the power some log e sin x. So this whole term is sin x. Now this is the integral we need to solve. So in this kind of integral where you have product of cos x and sin x, and the power of cos x is even, the power is even, what we can do is cos x let cos x equals to t. This implies minus sin x dx equals to dt. Therefore I integral becomes sin x dx we already have, so we get minus dt, and this is t square. Okay, so this becomes minus t square dt, and this is minus t cube by t plus c. So this becomes cos cube x by 3 plus c. This is a MCQ question, and my answer is not given as a choice in the MCQ. So, although there is an option none of the above, but I don't think that will be the answer. Let me check if I did it right or wrong. E to the power log sin x is sin x, of course. So we have, oh sorry, it was cube. My mistake. This was cube. This was not cos square x, but this was cube. So we have this is cube. So this will be 4. This will be 4, 4, 4, and now one choice matches. Okay. Let's solve the next problem. What is the next problem? Okay, it is sin 2x divided by a square sin square x plus b square cos square dx. Now in the numerator we have sin 2x, we can write it as 2 sin x cos x, 2 sin x cos x. Okay, and we can then substitute uh, either cos x square x equals to t or sin square x equals to t, because we will then get sin x cos x dx equals to dt, and it's sin x cos x is already there in the uh, numerator. So let's do the substitution. Let cos square x equals to t. This implies minus 2 cos x sin x dx equals to dt. This implies minus sin 2x dx equals to dt. Therefore, integral becomes minus, if we substitute sin 2x dx equals to minus dt, we get minus dt divided by from sin cos square x equals to t, we will get sin square x as 1 minus t, and over here we have b square t. So if I take a square common, from the denominator we get, and also minus common, we get 1 minus t divided by b square by a square t. So this is minus dt by no, it was not necessary to take out a square as common, because we have in the denominator a linear factor of a linear expression of t. So we can easily have the integral as a log. I mean, integral of something like this is obviously log mod ax plus b divided by a. So we can use this result in this example, in this problem. So let me rub this. We did not take out the a square as common. We can now so this becomes minus dt a square plus b square minus square t. Okay, so so the answer will be minus log of mod a square plus divided by b square minus a square plus c. Okay, and what is t? Cos square x. T is cos square x. Okay, so the answer will be 1 by a square minus b square log e uh, a square minus b square square x plus c. Can we simplify this term? Can we simplify this term further? A square minus b square log. If we take a square common, we get a square into 1 minus cos square x, that is a square sin square x. We get a square sin square x, and of course we have b square cos square x. So this is the answer. Yes, it is given as a choice in the MCQ problem. I hope this is right. Okay, let's see the next problem. The next problem is dx by root over sine cube x, and so we have a similar problem that I failed to solve in the previous video. So this is okay, 1 by root over this. This is basically sin x minus 3 by sin x to the power minus 3 by 2 and cos x minus 5 cos x to the power minus 5 by 2. And again, if we see, if we add up the powers, we are getting minus 4, which is again an even negative integer. So we can substitute. I am writing the concept used. M plus n is negative even integer, therefore we substitute tan x equals to t. So do the substitution, let tan x equals to t. This implies sec square x dx equals to dt. This implies cos dx equals to dt. Therefore, the integral becomes, I want to take out cos x, separate this out, and we are left with cos x to cos x for minus 1 by 2, and we have sin x 3 by 2. Sin x 3 by 2. We are left with sin x minus 3 by 2. Okay, so this is cos x minus to the power minus 2 dx equals to dt, and we have cos x to the power half, and I would like to have below also sin x uh, sin x to the power minus half. So we are left with this. This is dt by tan x, this, and this becomes sin x 1 by sin square x. Okay, now we can substitute tan x, we have substitute tan x equals to t, so this becomes t minus half, and this is again sin square x. So sin square x in the first problem we got t square by 1 plus t square. So sin square x is t square by 1 plus t square. So this becomes 1 plus t square divided by 4 t 3 by 2. Now this becomes this plus 4 4. So this becomes plus 1, 2, that's half. Plus t 4 by 3 plus c. So this becomes minus 2 by root t plus 3 by 4 t to the power 4 by 3 plus c. So this becomes minus 2 by root tan x plus 3 by 4 tan x to the power 4 by 3 plus c. So this is the answer we are getting. Let me check if I have this answer as a choice in the MCQ or not. Minus 2 by root tan x plus 3 by 4. No, it is not there. Instead of tan x to the power 4 by 3, there's a tan x 2 by 3 and 3 by 2. I might have done some mistake. Sin square x is t square. Sin square x is t square by 1 plus t square. Okay. So 1 plus t square divided by 4, 3 by 2. 3 by 2 is fine. T to the power minus 3 by 2. And what is this? 2 minus That's 3 by 2. That's 3 by 2, 4. This is half. I'm sorry. This is half. This will be half. So now we are getting, we will get 3 by 2. This will become 3 by 2, 3 by 2. This becomes 2 by 3 and 3 by 2, and 2 by 3. Over here we have 3 by 2. Yeah, now there is a choice for this. I hope this is correct. If I do any mistakes, please do let me know. I will appreciate that. Let's do the next problem. Problem number 5 is, what is problem number 5? Okay, it says x plus 2 divided by root over x square plus 5x plus 6, this. Okay, so we have a quadratic expression inside the root in the denominator. If we factorize the quadratic expression, we get x plus 3 into x plus 2, and we have x plus 2 in the numerator. If the derivative of the quadratic expression is coming 2x plus 5, and we have x plus 2 in the numerator, what we can substitute? We can manipulate the numerator like this. If we do, if you divide by half and multiply 2x plus 4, we have this. But I need 5, 2x plus 5 in the numerator. So if I do 2x plus 5 minus 1, and will this help? And now if I substitute the quadratic expression as t, then the derivative of the quadratic expression, but before that I have to split these into two integrals of the form 2x plus 5 x square plus 5x plus 6 dx. This will be solved, I guess. And what about the other one? What about this one? Okay. Now this, if we this is a standard result. I mean, if we have something like this, then definitely the answer will be what will be the answer? Can we say 2? This will be the answer. If you differentiate twice of root over fx, then it should be f dash x divided by root fx. Yes. So the first integral mm, becomes mm, the first integral becomes 2 into x square plus 5x plus 6. These two will cancel out. And let the other integral be I2. So this is basically root x square plus 5x plus 6 minus I2. Let's have the constant of integration, and now we have to solve I2. Okay, what is I2? I2 is integral of dx. We have a I think there is a standard result to solve integral of the form 1 by root over a quadratic expression. But just by intuition without knowing the standard result, let me see if we can do it. If uh, if we factorize the quadratic expression, it becomes x plus 3 into x plus 2, and definitely we can the numerator we have 1, we can express 1 as x plus 3 minus x plus 2. So x plus 3 to x plus 3. Or root over. I do not think this will lead to a very comfortable situation. So what I was thinking is, if we do this, uh, will do we get a expression which is easy to solve with whatever standard integrals results we know so far. So this becomes root over x plus 3 by root over x plus 2, and dx, and this becomes root over x plus 2 by root over x plus 3 dx. What we can do from here now? This is root over x plus 3 by or the second approach could be, if we can factorize, if we can express the quadratic expression as a square, like if we do this, x square plus 5x plus 6, if we try to create a whole square, like in the form of a square minus b square, what will it become? X square plus 2 x into 5 by 2 plus 5 by 2 whole square minus 25 by 4 plus 6. This becomes x plus 5 by 2 square What is how much is minus 25 by 4 plus 6? 24. It is 1 by 4. So this is x plus 5 by 2 square minus half square, and it is this in the root. So I think this approach will be a better one. If you can rewrite the quadratic expression in the form of a square minus b square. So this is this. So this becomes dx root over x plus 5 by 2 square minus half square. And we have a standard result. Integral of integral of root over 1 minus x square is sine inverse x. I think we have to use this result somehow. Okay, so if I try to rewrite the a square minus b square inside the root in the form of 1 minus x square, what do I do? 1 minus x square. T square minus sine square x. So what is derivative of sine inverse 1 by x? What is the derivative of sine inverse 1 by x? This is for the 1 by x part, we will get 1 this thing, and for the sine inverse x we will have root over 1 minus 1 by x square. Oh no. T square. We have t, then x square minus 1, x square minus 1, the x will go upward 1 by x. So at this stage what if we substitute t square plus a square root over if this was half square minus x plus 5 by 2 whole square, then basically it is of the form this. Is there any standard result for this integral? Because if it was dx by root over a square minus x square, I could have manipulated the expression and take a square common, and the result would be sine inverse x by a. But let me check, do we have any standard result? No. Sine inverse. What we can do, what we can do, what we can do. Okay, so let's see. Possibly we have to use some trigonometric substitution. Let me check. Cos square t squared minus something. If we substitute t, what happens? Dx equals to dt, and the integral becomes dt by root over t square minus half square. T square minus half square. And t equals to half cos theta. Is there any standard result for this t square root over t square minus a square? Substitutions. Sin theta or cos theta. Yes, there is a standard result. There is a standard result. The integral this is based on a standard result. The answer is log for this integral. It is log mod t plus root over t square minus half square. So now if we substitute back, so this becomes, we are doing I2, okay, so this becomes log e, t was x plus 5 by 2, so x plus 5 by 2 plus this was root over x plus 5 by 2. So this was basically the quadratic expression originally, and okay, this is I2. So what the final answer becomes? The final answer becomes root x square plus 5x plus 6, and this was minus I2 minus log e x plus 5 by 2 plus root over x square plus 5x plus 6. Let me check if this answer is there in the as one of the choice in the MCQ or not. Which one I did? Yes, it minus log e. There is a half before log and x plus 5 by 2. Okay, plus there is a half, y half, t square minus why there is a half. This is let x plus 5 by 2 equals to t, we have dx equals to dt, then root over t square minus half square and equals to log e t, let me check the standard result. Dx by root over x square minus a square is log x plus so t plus t square minus half square and log e x plus 5 by 2 this. I don't know why in the the choice there is a half over here. I'm not getting half. Anyway, please let me know if I did any mistake over here, and there should be half before this log term. Is there any question left? No. So that was all for this video. If this video was beneficial, then please like it, share it with your friends, and also please support me by subscribing to my channel, and please do not forget to press the bell icon so that you will be notified by my future videos, as I will keep on uploading videos on solving problems from the book Objective NCERT Fingertips Mathematics for both class 11 and 12. I've started with the integrals of class 12, and I will also start solving the problems from class 11 chapters as well as from other class 12 chapters. So thanks for watching, and until the next video, take care and bye.